Photon do not experience time. Hello and welcome to today's video that is going to answer the question of whether photons experience time. Before diving into the topic, let's have a brief understanding of what photons are. Photons are particles of electromagnetic radiation that can travel through space at the speed of light. They carry energy and momentum and are responsible for all forms of electromagnetic radiation, including visible light, X-rays, and radio waves. Now, the question arises, do photons experience time? To answer that, we first need to understand the concept of time. Time is a measure of the duration between two events that have occurred or will occur in the future. It is often said that time is relative, and this is precisely where our understanding of photons and time comes into play. The theory of relativity, proposed by Albert Einstein, states that the laws of physics are the same for all observers in uniform motion. This means that two observers moving at the same speed will observe the same physical laws and phenomena. However, this theory also proposes that time is relative to the observer's speed and position. To understand this, let's imagine two observers, A and B, who are moving at different speeds. If they both observe the same event, they will measure different times between the event's occurrence and when they perceive it. This phenomenon is called time dilation. Now, let's extend this concept to a photon. A photon travels at the speed of light, and according to the theory of relativity, time slows down as an object approaches the speed of light. This means that, as a photon moves at the speed of light, time for the photon would appear to have stopped. As a photon moves at the speed of light, it experiences space differently from any other object due to its light-like nature. For a photon, the distance in the direction it is traveling is compressed, which means that if a photon travels from point A to point B, it will appear to travel a shorter distance than if it were a slower particle. Moreover, it is also essential to understand that photons, being massless particles, do not experience the effects of gravity. This means that they do not experience time dilation, which is a result of gravity's curvature in spacetime. To put it simply, the speed of light is constant for all observers, and as a photon travels at the speed of light, time for it appears to stop. Hence, photons do not experience time. However, it is important to note that this does not mean that photons do not exist or that they do not have a physical presence. They do, and we can observe their effects and properties through the various devices and instruments used in modern-day physics. In fact, photons are crucial to our understanding of the universe. They allow us to see and study celestial objects like stars and galaxies, and we use them in technologies like cameras, solar panels, and medical imaging. In conclusion, the theory of relativity proposes that time is relative to the observer's speed and position. As a photon travels at the speed of light, time appears to stop, and it does not experience time dilation. This means that photons do not experience time, but they certainly have a physical presence in the universe and play a vital role in our understanding of it. Thank you for tuning this video, and I hope it has helped you gain a better understanding of the concept of time dilation and photons. If you have any questions or comments, please leave them below, and I'll be happy to respond. Don't forget to like and subscribe to our channel for more exciting videos. Thanks for watching.